Alright guys, section 4.2, we're going to get now some properties of triangles, and then we're going to be using those properties to solve for some missing pieces. So the first one that we're going to get is something called the triangle sum theorem. Super simple, and it's probably something you guys already know, but it just says that all three angles of any triangle must add up to 180 degrees. Right, so that's going to be true for every single triangle you could ever draw. Angles have to add to 180. Guys, again, if you're writing this down on your own piece of paper, you do need to copy down this theorem, so make sure that gets included in your notes, as well as examples 1 and 2 that you see right here. So let me just talk through these, but again, you do need to write these down if you don't have the notes printed. So as I look at example 1, it's asking me to find my missing angle. So here's something that you will do forever in math, because you'll continue working with triangles no matter how high in math you go, all the way through calculus. So triangles always play a big part in math, and the one thing that will continue to come up in all those levels is just knowing that the three angles add up to 180. So if I know two of the angles, right, so together those add up to 60. So I know that my two that I already have plus whatever angle t is must add to 180. So all I have to do is subtract the two angles that I know from 180 to see what's left, right? And so now I can see that angle t is 120 degrees, and we have our missing angle. Take a look at this one. So here's something that's going to link back to something we've been doing since chapter 1, which is my idea of vertical angles, right? So again, those vertical angles are going to pop up in chapter 4. Let's just start with angle 1. Okay, so if this is all I had, if that was the only triangle I could see, I would do the exact same thing that I just did in example 1. I would take the two angles that I know, and I would add them together, and I can figure out that they add up to 148 degrees. So if I just subtract that 148 from 180, I can figure out what that third angle is. So that third angle that they're calling angle 1 is 32 degrees. Well, if angle 1 is 32 degrees, what do we know about angle 2? Right, angle 2 would also have to be 32 degrees because they are vertical angles, right? And so we learned this a long time ago. That was just called the vertical angles theorem. It says that vertical angles are congruent. Well, now that we know that this is 32, I can do the exact same thing that I did here and say that 32 plus 108 plus whatever that is has to add up to 180 degrees. So there's the second equation that we're seeing right there. Again, I'm going to add up the two that I know. They come out to be 140 degrees. I can subtract that from 180 in order to figure out my missing angle. So there's just kind of a common way that we're going to be using that. I like these 4 exercises because they throw in some of the other concepts that we've already learned. And so let's go through these 4. Again, if you are writing down your own notes on your own piece of paper, you do need to copy down these 4 drawings and then do the math alongside of it here. So for number 1, let's just take the idea that we already know. Again, I know that my 62 plus my 90 plus whatever angle 1 is must add up to 180 degrees. So let's just write that down. So let's add up the two angles that we know. So if I add those guys together, they're going to come out to be 152. So if I always subtract the two angles that I know from 180, that's going to leave me with that third angle. So if I subtract 152 from both sides, then we figure out that our missing angle would be 38. Because I want to point something out, because this is going to play a big part in a future chapter. We know that these must add to 180. So there's a shortcut that's going to come up that we're going to be using a ton when we get to our chapter on right triangles. Because when you get into right triangles, that introduces us to the level of math called trigonometry and all that fun stuff that we will begin later this year. So I wanted to point something out to you. In a right triangle, which obviously this is a right triangle, knowing that all three angles add to 180. If this is 90, that means that the other two acute angles must also add to 90, right? Because 90 plus 90 is 180. So again, if this is 90, I know that these two add to 90. So one of the shortcuts that we're going to be doing later on is, instead of looking at all three of them adding to 180, if this is 90, all we have to do is say that this plus this equals 90, and I can figure out my missing angle that way. So kind of a little shortcut if that sunk in with you. If not, don't worry, we can still take this approach for now. Jump over to number 2. So one thing I'm seeing right away on number 2 is I have an isosceles triangle because two of my angles are congruent. We're gonna learn later on that if these two angles are congruent, then this side and this side must also be congruent. So we end up with an isosceles triangle. But anyway, if that's 30, based on the markings that I see, this guy is also 30. And so now I can take the same approach that we took here, and I can say that my angle 1 plus the other two angles must add to 180 degrees. So again, if I know two of those angles, I can always subtract that from 180 in order to figure out my third angle. So that's how we can get the measure of angle 1. All right, jump down to number 3. I need to come up with the measure of angles 1 and 2. Let's start over here because we know more information. So here's something we just talked about. I'm going to see if you caught the shortcut on this. If this is 90, what would I know about angle 2? So if this is 90 degrees, then I know that these guys must add to 90 in order to get a total of 180. So if that's 30, what would this have to be? That would have to be 60 degrees, right? So that they add to 90 degrees. So it's kind of a nice little shortcut. I already know that angle 2 is 60 degrees, just based on that information. But let's just play it out the way that, without the shortcut. So what if we didn't notice the shortcut? All right, then I'm going to look at this triangle and I'm going to say, okay, what are my three angles? I got a 30 right there. I have a 90 right there. Plus whatever angle 2 is, has to add to 180. So if I just add up the three angles, set them equal to 180, we have our equation. We add up the ones that we know so that we can subtract them from 180 in order to get angle 2. Guys, one thing that we notice on this is what we call a 30, 60, 90 right triangle. Well, as I look on the other side, one of the properties that we have talked about since chapter 2 was the idea of perpendicular lines. If this line is perpendicular to this line, which it is because I see the right angle here, well, if this is a right angle, what would have to be true about this guy? He would also have to be a right angle. So that's something we've worked on since chapter 2. But if he's 90, then this guy also has to be 90. There's several ways we came up with that. You could look at this as a linear pair where they have to add to 180. Therefore, if this is 90, this is 90. We also talked about the idea of perpendicular lines forming right angles, right? And so if he's a right angle, he has to be a right angle as well. So anyway, I'm now looking at the same information in this triangle that I was looking at in this triangle. So again, if that's 90 and that is 60, just like this is 90 and this is 60, what does that leave you with for your third angle? So if we start reasoning through some of those concepts, we should be able to see that angle 1 has to be 30 degrees. And so if I see that, I can just identify that information. If you didn't notice some of those shortcuts, we would just take the same approach that I took right here. I can still say that 60 plus 90 plus angle 1 is 180. So if I don't recognize a shortcut, no big deal. I just come back to my triangle sum theorem, which says that they all three have to add to 180, and then I could solve for my missing part. All right, last one on this page. Let's take a look at number 4. Again, draw that image if you're taking your own notes on your own paper. But again, as I look at this, we're running back into the idea of vertical angles. So let's start with the one that we know for sure. So I know that my 66 plus 58 plus whatever angle 1 is must add up to 180. So if I add those two together, let's add the ones that we know. Let's see, that would be 124. So we're going to add up the two that we know so that eventually we can subtract those from both sides in order to figure out our missing angle. So now if I subtract 124 from both sides, we figure out that angle 1 is 56 degrees. Right here we're noticing those vertical angles, so if angle 1 is 56 degrees, then angle 2 must also be 56 degrees. So let's set up one more equation here. I now know that 56 plus 50 plus angle 3 equals 180. So there's our second equation. Let's do the same approach. Add those guys up. They add up to 106. Subtract that from 180. And we have our final angle. All right, let me flip you over to the back side. And we're going to get one more rule of triangles here, something called an exterior angle theorem. So guys, again, if you're taking your own notes, please write down what you see in the box right here. It's the other big concept of this lesson. So an exterior angle, you know, when you think of the prefix x, right, what does that prefix always represent? It represents the word out or outside, right? And so like if you exit a room, you are going outside of the room. So if you think of that prefix and what it means, so we are talking about an angle that is on the outside of a triangle. So as I look at this drawing right here, so you guys see these three, that one, and that one. So those are the three interior angles. They are inside the triangle. Angle 1 is what we call an exterior angle because he is outside the triangle. So here's what the exterior angle theorem says. It says that the exterior angle is equal to the sum of the two remote interior angles. In other words, if this is my exterior angle, it would equal the sum of the two angles that it is not connected to, like A and B, right? And so that's our exterior angle theorem. So as you look at this drawing right here, again, if you're taking your own notes, please write down this example and this example in your notes. So as I look at this, I know that angle 1 is equal to the sum of the two angles, interior angles, that it's not connected to. So I know that the 60 plus the 80 is equal to angle 1. And so that's the setup that you see right here. So if I just add those two angles together, they add up to 140, which means angle 1 is 140 degrees. I want you to see a connection to something that we've learned before, though. As I look at this, what do I know about this angle and this angle? Right? We've seen those since the beginning of the year as a linear pair. And what do we know about linear pairs? They add to 180. So there's two ways to look at this. I could have subtracted these from 180 in order to figure out my third angle is 40 degrees. And then I could have said, well, based on the linear pair postulate, I know that linear pairs are supplementary. Therefore, 180 minus 40 tells me that angle 1 is 140 degrees. So we can use old information in order to come up with this value, right? It just takes longer. So the idea of the exterior angle theorem gets you there quicker, right? But I do want you to keep in mind this linear pair relationship because that will come up in other problems. So look at example 2. So again, on this one, I recognize the exterior angle right here. I know that the exterior angle is equal to the sum of the two interior angles that it's not connected to. So 78 must equal x plus 55. So there's the equation, and then a very simple solve to figure out what x is. Okay, let's try some on our own. So again, if you're taking your own notes, please write down these diagrams before you continue on with the video. But we always want to set up an equation for these guys. So we now know that the exterior angle of angle 1 is equal to the sum of the two remote interior angles. So that would be our setup. All we got to do is add those guys together, and we get 115 for angle 1. Jump over to number 2. All right, so this one is now kind of leading you into the idea that I was talking about before. You can solve for angle 1 or 2 first. It doesn't matter, because we now have theorems and postulates that tell us how to get to either one of those guys. So let me give you a couple ideas, because there's more than one way you can do this. So it's a matter of whichever way you want to take. I know that these 3 angles add to 180. Right? That's the triangle sum theorem. So I could say that 25 degrees, I shouldn't say angle for that, 25 degrees plus 35 degrees plus whatever angle 2 is adds to 180. So that is the triangle sum theorem that we did in the first half of this lesson. So you could take this approach. Nothing wrong with it. Those guys add up to 60. Subtract, and we figure out that angle 2 is 120 degrees. So if you went that route, how would you now figure out angle 1? Because now you got 2 paths to get you angle 1. So there's a couple ways you could do this. If I know this is 120, and I know these are a linear pair, well, a linear pair has to add to 180. So if that's 120, he's got to be 60. So I could use the idea of a linear pair to figure out that angle 1 is 60 degrees. But I certainly didn't have to go that route. I could have gone a very different route, and I could have used the exterior angle theorem, which says that angle 1 is equal to 25 plus 35, and that also would have given me a value of 60 degrees right here. And then I could have said, well, these guys are a linear pair. If he's 60, he's got to be 120, so that they add to 180. So there's a few different approaches you could use on this. I want you to see how all those relationships are connected to each other, right? And we could take different paths to get to that right answer. All right, let's go on to number 3. So this one is taking us back to what we learned in chapter 3, which is the idea of parallel lines. And this will come up in a big way for the rest of this chapter. So I want you to remember a couple relationships. Here was the main drawing that we dealt with in chapter 3, right? Looked like this, right? Where you had some parallel lines cut by a transversal. And so we had things like alternate interior angles, and we know those are congruent. We had alternate exterior angles, which are congruent. We had consecutive interior angles, which are supplementary. They add to 180. We also had, the fourth one was corresponding angles. Those would be ones like maybe this guy and this guy, which were congruent to each other. So you got to hang on to those relationships, especially when you are looking at parallel lines, right? It's pretty much always going to go back to this drawing when you see parallel lines. So let's take a look at these guys. So if this line is parallel to this line, that means this angle and this angle are alternate interior angles, right? And as we learned in chapter 3, alternate interior angles are congruent, which must mean this is 60 degrees. I can do the same thing right here with angle 1. This angle 1 and this angle must be congruent to each other because they are alternate interior angles, and I know that based on this parallel line and this parallel line. Okay, so that tells me that angle 1 is 60 degrees. So now you have like multiple ways of coming up with angle 3, right? I do know that it's an exterior angle. So if I just look at this triangle, I know that angle 3 is equal to 60 plus 60, which is 120. That's just one of the ways you could get that answer. Again, we've already talked about other ways you could get there. As long as we get to that idea that angle 3 is 120, we're in good shape. Here's the last one. Again, guys, if you're taking your own notes, copy this diagram down before you do the problem. So as far as the measure of ABC is concerned, that means they want the measure of angle B, right? ABC means we are looking at A, to B to C, so the one in the middle is always the angle that we are finding. So as I look at this, a couple things we're going to need to do here. One is, we know that my 95 plus angle B is equal to 145. Right? That is the exterior angle theorem. What I want you to notice on this is, why did I not put 2x right there? Why did I just put angle B instead of 2x? Well, you have to look at what is being asked of you, right? This problem did not ask you to solve for x. If it did, I would have put 2x right there, and I would have solved the equation for x. But that's not what this one asked for. This one asked for, what's the measure of angle B? Right? So all I have to do on this one is subtract my 95 to figure out that angle B is 50 degrees. Right, and that's it. So that's where I get to stop, because that's all they asked for. If they said solve for x, well, now I could say that, okay, then if that's 50 degrees, then 2x is 50 degrees, and now I know that x is 25. So it's really just a matter of reading directions carefully and finding whatever they are asking you to solve for. That is it for section 4.2.